we've mostly studied finding the volume between the surface and the xy plane, but let's look at finding volumes between two surfaces. So I have two strange surfaces, and I want to find the volume between them. So what's going to end up happening is they're going to cross over at some point, and they're going to create some sort of bounding bubble region, and we want to find the volume of that bubble region. So what I've got is some surface 1 minus x squared minus y squared, and you might recognize that as a elliptic paraboloid, and it's really not even elliptic, it's kind of like a circular paraboloid, and then it's going to be bounded below by z equals 1 minus y. So that's just the equation of a plane. So you're going to have this plane, and it's going to cut into this paraboloid, and you're going to have this little bubble area. So what we want to do is we want to find a crossover region. We want to find all the places where these things intersect. Well, if z equals this and z equals that, then the crossover region is where they equal each other. So I can say 1 minus x squared minus y squared equals 1 minus y. And the ones will cancel. So what I end up with is that x squared equals y minus y squared. So ultimately, my crossover region it goes from the case where x is the negative y minus y squared to positive y minus y squared. So that's the idea here. Probably a better way to write this would be, if you factor out the y, you get y 1 minus y. Because that's going to tell us a lot about what's going on here. The reason why you want to do that is for this bounds. So if you look at the fact that x can only go from here to here, what that tells me is that y, you can't have a negative in a square root. So if y is positive, or y can't be negative, right? It can't be negative here, or this value would be positive and this value would be negative, so that blows up. So y can be 0, not a problem, and y can be positive, but it can't be larger than 1. If y is equal to 1, this whole thing falls out as well. But if y were like 2, this would be 2 times a negative number. So what that tells me is y can only go up to 1, but it also can't go below 0. So that gives us information on the bounds. It says, okay, well, y can only go from 0 to 1, and x can go from, that was bad, y minus y squared to positive y minus y squared. And so the next thing we want to do, now that we have the bounds, is we want to integrate this thing. We want to solve it. Well, if you look at this, you say, okay, well, the y values those are constant values. There's numbers, and the x values are functions of y. So that means we need to integrate with respect to x first. So I say we want the 0 to 1. That. And we want to integrate this function minus that function. So we say 1 minus x squared minus y squared minus 1 minus y dx dy. Now, another way to do this is you could set them up as two separate integrals. That's what I actually have in my notes, is you do this integral, so you find the volume of that down to the y-axis, and then you subtract that integral down to the y-axis. Either way is fine. It all works out. So we can set this up and simplify. We get 0 to 1 I'm going to call this G1 of y and G2 of y because I don't want to keep writing that nasty thing there. And the ones cancel, so you end up with y minus y squared minus x squared dx dy. So when we integrate, we get 0 to 1, y minus y squared x minus 1/3 x cubed. So one thing I did note, I didn't say this before, but we should have, that again, this is an even function. This is an even function because these are constant and this is squared. So I really could do that. So now I have 2, 0, square root y minus y squared. This is really going to help me out here because now I have 2 integral from 0 to 1 y minus y squared to the 3 halves minus 1/3 y minus y squared to the 3 halves dy. So these are the same thing. So this is really just 2/3 of this thing. So I get 4/3 0 to 1 y minus y squared to the 3 halves dy. Okay. So there was a very interesting substitution that happens here. And I'm not going to expect you to understand this. Again, it seems like we keep doing trig substitutions over and over, and they're not the only ones you have to do, but if you don't do those, like everything else is uninteresting because it just falls out and just integrates directly. So I'm going to do a trigonometric substitution of y equals 1 plus sine of theta over 2. And that's a little bit of a cheat because you technically have to get this and you have to do some clever factoring and it really tells you what y needs to be, but I backed it out. So that tells me that 2y plus 1 equals sine of theta. So 2 dy equals cosine theta d theta, or that. So this also tells me that y squared is 1 plus sine of theta over 2 squared, which is 1/4 1 plus 2 sine theta plus sine squared theta. So let's just go ahead and sub this in. What we get is 4/3. So when y is 0, sine of theta is 1, so that's pi over 2. When y is 1, sine of theta is 3. Oh. When y is 1, sine of theta is also 1. That's a problem. That's a huge problem. Because that would get me pi over 2. And that's gonna be an issue. I'm sorry, guys. Give me just a second. Oh, that happens because when y is 0, this was -1. So that's negative pi over 2. My bad. I was like, why is this happening? Plugging in, we now have 1 plus sine of theta over 2 minus 1/4 1 plus 2 sine theta plus sine squared theta to the 3 halves d theta, which is 4/3 negative pi over 2 pi over 2. So I'm going to do some quick algebra here. So the sine thetas are going to cancel. 1/2 minus 1/4 is 1/4. So you get 1/4, and then you have minus 1/4 sine squared theta to the 3/2 d theta. You factor out the 1/4 and take it to the 3/2, you get 1/8. So I pull the 1/8 out. So now I have 1/6 negative pi over 2 to pi over 2, 1 minus sine squared theta. Oh, that was always cosine of theta d theta. And the 1/2 should have turned that into a 2/3. Should be a 2/3. This now becomes a 1/12. Cosine of theta d theta, which becomes 1/12, negative pi over 2 to pi over 2. So this is cosine squared. Cosine squared to the 3/2 is cosine cubed. So now we have cosine to the 4th theta d theta. And decided to look it up and alright, so I had 4/3. I'm checking my notes here. I had a 4/3. That should have become a 2/3. It did. And that should have become a 1/8. So when 1/8 got multiplied by this, that should have been 1/12. And then this is an even function, so that becomes 1/6. And there is something called Wallace's formula. Again, this is that same cosine of the 4th we saw in another problem, which gets us 3 pi over 16, getting us a final result of pi over 32. So again, it's a lot of work. Realistically, probably somewhere around here is where you're gonna, hopefully you'll have something that's a lot easier to integrate there instead of having to go through a pretty complicated trigonometric substitution and solution. But the idea here is we can find the difference between surfaces if only we find their crossover region, we get the bounds, and then we subtract the surfaces, and that'll give us that region between to get the volume.